This video will demonstrate how to conduct a progressive failure analysis of a composite laminate using HeliusCompositePro. A progressive failure analysis looks at each individual ply in a composite laminate, and when that individual ply fails due to a composite failure criteria, that individual ply's mechanical properties will be degraded to a fraction of the pristine stiffness. What this will allow is it will allow the engineer to look at the full failure history of a composite laminate, from first ply failure all the way through to last ply failure, to get a more accurate determination of when ultimate catastrophic failure of the laminate occurs. The progressive failure tool is found under the laminate module, and the first step is to create a composite laminate. I'll do this by first inserting an individual ply. I'll choose this ply to be AS4 3502, a common carbon epoxy material. I'll give this ply a thickness of 5/1000 of an inch and an angle of 0 degrees. Now I'll select this ply and repeat it twice and start to build my laminate. Now I have 3 plies, and I'll change the middle ply to have an angle of 90 degrees. I'll give my laminate a name of Demo. Under the Laminate Loads tab, I'll choose to load my laminate by strain, and I'll assign an axial strain of 1.5% to my laminate. Now I can choose the failure criterion in which to evaluate failure in each composite ply. I'll choose Christensen for this example. And for the Christensen failure criteria, I prefer to use a degradation factor of 0.1 for all my material directions. Now I can click on Calculate, and we'll get a series of stresses and strains in the laminate. And more importantly, for progressive failure, we'll get a failure index, the failed ply numbers, and the failure modes for each ply in the laminate. As we scroll down, we see that in increment 76 of 200, that ply number 2, the middle ply, has failed with a failure mode of 1. Now, to get a description of what these failure mode values are, we can open up the HeliusCompositePro User's Guide. And in Chapter 5, 5.8, we have available failure criteria for composite materials. And if we scroll all the way to the end of this chapter, we have a convenient table that summarizes the different failure modes available for each failure criterion. So we can see for Christensen, a failure mode of 1 indicates matrix failure. A failure mode of 2 indicates fiber failure. So, at a strain level of roughly 0.57%, we can see that our middle ply has failed due to matrix failure. If we continue to scroll down, we see that at a strain value of roughly 1.3%, we can see that our top and bottom plies have failed with failure mode 2, fiber failure. So a convenient tool to see how this has an impact on the ultimate load carrying capability of our laminate is the plot tool. In this case, I'll plot stress versus strain in the axial direction. So we can see as we increase the strain along the x-axis, the load increases along the y-axis. Our first failure event occurred at roughly 0.5%. The laminate was able to continue to build load, up until a point of about 1.3%, where we see a catastrophic load drop, indicating that our laminate has completely failed and is unable to accumulate more load.